Okay. So I really for a session like this, we do usually have a structure or format of how we go about things. But due to the nature of things and how things are being coordinated, I actually asked um, the the host now that is there any structure on how we should go about this? But he didn't give me any structure. But I'll just use my discretion as he mentioned, uh, and touch on one or two things. But one thing I want to say first is I think I used the first 8 years of my life learning what is statistics, what is data analysis, and up to now I am still learning. So and then uh, I think okay, after national diploma, BSc, and MSc, so currently in my third year of PhD, so I am still learning what analysis is. So it means data analysis is a process that you continue to learn, because the truth of the matter is the data world is changing every day. Like somebody said that the data information we have in this world, when you pile it up from the ground, it gets to the sky. So that tells you the level of data we have to consume as human being of about over 7 billion people. So the process and the management of data are evolving every day. Now we have what we call computational data, we have computational demography, we have computational analysis. So, but for the purpose of this class, what I can do at this level, considering the time we have and then the kind of facility that is available, is to try as much as possible to introduce you to at least the first level of data analysis, things that you must know. At least if you are not a statistician or you are not a data analyst, what are the things that I must know so that I'll be able to guide whatever research I want to go into. I think at this point that is what is more important. Then if we have other section, then we can talk about what are the things that we can go further from there. So I do not have any slide to share or anything, so I don't know. I'm not sure if I will share my screen as well, but if it warrants me to share my screen, I will. But let's see how it goes first, because I have just about 60 minutes to do some things with the the people online. So I try to get what the definition I will give data analysis. So I have here data analysis is the process of inspecting, cleansing, transforming, and modeling data with the goal of discovering useful information and informing conclusions and supporting decision making. So now I'm going to take it one by one. Data analysis is a process of inspecting. So what does that mean? Uh, if we have our raw data, for instance, a lot of times I make use of secondary data sets. You have to check if your data set, you have to inspect if your data set is in line with whatever you have in mind to write about. What do I mean? Let's assume there is a database called Demography Earth Survey. It's actually a database that conducts data collection in about 81 low and middle income countries around the world. So let's assume I want to check the knowledge of HIV of people in sub-Saharan Africa in that data set. So first thing I need to do is to inspect the nature of the data set. I need to check if whatever my objective is, will it answer it? Is it possible for me to answer all my objective, or I will still need to do some level of maybe qualitative analysis, qualitative research method to augment my results. So in this sense, you have to inspect to be sure. And then the next one is cleansing. Data analysis is a process of inspecting, cleansing, or cleaning. Now, after you have checked that, okay, you can measure the level of knowledge of HIV among the people, maybe among adolescents in sub-Saharan Africa, you need to clean your data set in such that, because in that data set, we have what we call non-response. I don't know if I should just practicalize, at least I think on this definition, I should be able to share my screen and let's just do some work on the using data so that you can, because the truth of the matter is, sorry, the data analysis is not sweet if it's not hands-on. So it must be an hands-on practice for us to be able to, if I continue saying like this, you might not really get what I'm trying to say. So I'll see if I can share my screen. Sorry, the person that started do you give me the right to share my screen?
Yes, you are the host now, and everybody can even share screen now. So you are the.
Oh, sorry. Okay. So you can see my screen now, right? Can somebody? Can you see my screen?
It's up.
It's up. Okay, thank you. Okay, thank you. So let me use oftentimes I use data to analyze my data. So I already have demographic Earth survey data sets on my laptop. So I want to call up the data so that we can do one or two things so that you see what I'm trying to bring up with the definition we have here. Definition of data analysis that we have here. So I'll go here, just like our normal, when we want to open Excel, and when we want to open a new Word or bring in new document on MS Word or Excel. So it's normal. Now this is data software. It's more or less like SPSS, but it's an advanced software that gives you room for commands. You can write code just like when you use your Python or when you use your R. So a lot of times I prefer to use this more than SPSS. And maybe for some reasons, you also see why I prefer using this. If we can get to that stage, I will explain. So I have my data set here, Sub-Sahara latest DHS data sets. I have from 2010 to 2019, all Sub-Sahara countries that DHS, Demographic Health Survey, collected data from. So let's assume we want to go to Nigeria, want to use Nigeria data set. So this is Nigeria data set. The latest one was in 2008. So this is the DTA file. Oh, sorry. Before that, I have to make sure that my system, my software recognizes that the file is big. First command, we have set more off. Set mass var, I think 6,000 should be okay. So now what I've done is I speak to the statistical data analysis software to enable me to bring in large data, because Nigeria is over 220 million people. So we have a lot of data sets about people. So it will accommodate it now, since I've given the command that the data is large. So going by the definition, data analysis is a process of inspecting. So let's assume I want to look at contraceptive use, for instance. If I come here where I have variables and I put contraceptives, you just type. Now, this function I just did now, SPSS cannot give me this kind of easy function like this on different interface that I don't have to be going up and down. You understand? So I have now in the whole of that data set, these are the information on contraceptives. So probably I want to talk about type of contraceptives that people use, currently using. So we say current contraceptives method. I put the variable here. That is what we call TAR. TAR is like looking at the frequency of the variable. So I have the information on contraceptive use in Nigeria and the type of contraceptives they use. So meaning my objective can be achieved. So that is one. So data is a process of inspecting. So I've inspected that, okay. Then cleansing or cleaning. Then I will now look at it that, okay, all of this data, is there anything that is not that I don't need? We have the first one is not using. Those are the people that are not using contraceptives. We have people that use pill. We have people that use IUD, injections, male, blah, 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 blah. But if you notice, now there is what we call other modern method. That was before the last. In this kind of situation, some persons will prefer to exclude this from the data set. But again, there is a command that we usually use to check if there is what we call non-response. If you have non-response in your data set. So all you just need to do is that the variable code is this. This is the variable code. So you type the variable code v312 slash, comma m. The comma m means mixing. Means if there is any missing data or if there is any non-response data. If there is any missing or non-response data, you will see it up here. But because there is no missing or non-response data, we still have the same thing we have up there. So meaning this data is clean, this data is okay. I don't know. I think we'll have one that should be with missing data. Exposure to need for contraceptives. Let's look at this. Sorry, I just wanted to see where you would you might need. Okay, this one is complete as well. So invariably, you have to check all your variables one after the other like this to be sure that you do not have, in any case, you do not have missing variable. Genital sperm. Sorry. Like for instance, I just call up another variable now. Add genital sore or ulcer in the last 12 months. This is a question that was asked on the field. Some person said no, some person said yes. Some participants said they don't know. Now, let's see. They don't know, definitely you don't need a response of we don't know, because obviously it's going to spoil your interpretation at the end of the day. So let's see if there is also what we call missing data among. Okay, there is no missing data here too. I know we'll get okay, good. We have missing data here. A question: flesh removed from genital area. Now you are doing inspection of your variable, which is part of data analysis. Now you can see that the first, let me see that. Okay, let me remove the M. If you look at the last frequency analysis I just did, we have no, we have yes, we have don't know. But if you look at the one I did first, we have no, we have yes, we have don't know. We have something like a dot with 37,033 frequency. So what this is telling you is that when they were collecting the data, there were 37,000 plus people that did not attend to that question. And obviously, you will not need these people to be in your research, Because at the end of the day, it's going to be biased because there are 37,000 people that you're talking about that they did not even attend to the question. So your inspection will actually make you to remove this. So we have a command we use in removing it. Very simple. We just say, now another good thing about Stata is that you speak to Stata as if you are writing English. And that's the same thing as Python and R. Unlike SPSS that you just have to do a lot of things manually, or Excel that you have to do a lot of things manually. Oftentimes I use Excel, but it depends on what I want to do. So with this, you can just say drop. Now you say, sir, now the first thing is you have to check what is the number. Now there's what we call, it's like a nomenclature when you're coding your questions from the field. If you check this question now, flesh removed from genital area, the 0 is representing no, yes is representing 1, don't know is representing 8, and we don't need the last one with dot. We don't need this guy, so we want to drop this guy. So you just need to say drop if G103, that's the variable name, equals dot. Dot is the representing, is what is the nomenclature that is used to represent those people that did not respond to the question. So if you press enter, it will tell you that 37,033 observations deleted. You see, so it means those people are out of your sample size, which is better for you. So that at the end of the day, your data will not be skewed or your data will not be biased. So in a nutshell, that is what we call inspecting. What you have done is just to make sure that you have inspected all your variables, and you have to do this on each of the variables one by one. Now, transforming. What do we mean by transforming? Data analysis is a process of inspecting, cleansing, transforming. Okay, let me go back. Now, we want to transform this data. This flesh removed from genital area. Let us want to transform it. Because I do not need no, I do not need don't know. I only need no or yes for those that have had their genital removed before. So I can say, okay, and I've gotten the numeric variable. I can say recode G103. Now I want to transform my variable to make sure that to suit what I want. G103 is 0, so be equals is 0, and then I can say name it as no genital cutting. And the next one will be, the second one is 1 equals 1. Now it gets to a point why as a data analyst, you have to take some very hard decision from your raw data in order to keep some sample size and to make sure that your sample size is justifiable. Now, on the field, as a data collector, if I asked you a question, your genital area, was it cut? And you told me you don't know. A lot of time, it might mean that it was cut. Sometimes it might mean that it wasn't cut. So you, as a data analyst, when you get to this point, and you don't want to lose, because you can see that our sample size has reduced from 41,821 to 4,788. And if we drop the people that say they don't know, it means we are going to drop additional 982 people. So sometimes what we do is we add it to people that said no. Because a lot of times, if you are caught, you will definitely know that you were caught. It's just like somebody that said, are you using contraceptives? Said, I don't know I'm using contraceptives. Definitely somebody like that is not using. So yeah, you can say, okay, I want to add it to people that claim that they know that they were not caught. So you come back to command area. I'm not sure if you're seeing my command area very well. Command area. So you look at the nomenclature number, then you say space 8. That means we've added those people that say they don't know to be part of no genital cutting. Then we say 1 is equal to 1. Then we say these people add genital cutting. Add genital cutting. And then we close it. And then we say this is now where you want to transform your data. I say you generate, command generate genital cutting. Now you've merged all the data to suit all the variables to suit what you want. So let's see. Sorry. So you can say G103 sorry, I'm having some. Sorry, 8. Sorry. So we have now this is it, and that's another thing about Stata. You really don't have to memorize. You just have to know the process. You just have to know how to play around it. When you have issue with your coding, you can always have a direction or something. You can see that the first error was the number of the new transform variable should be the same. No, it was trying to tell me that, okay, yes, you want to transform your variable. However, genital cutting, whatever you are putting, of course, you can still use genital cutting too. You can still use genital cutting too, but just that you have to, you can still use genital cutting too. Just that you have to make sure that it conforms with the law of coding. You can see it goes now because all I just did was to put underscore between the genital and cutting so that it will admit it as a variable, as a string. Yeah, as a string. So now if you say tab, that's frequency, you want to see what is inside genital cutting. Now say genital underscore cutting. You can see now that our variable has been transformed. So you have to, as a data analyst, you have to know how to do this because it's part of the definition of who a data analyst is. We've been able to, we've done the inspection, we've done the cleaning, we've done the transformation. Now, the last one is that you have to learn how to model data. That is the modeling, because it's the modeling that will tell you whatever your variable you want or whatever decision you want to take, whatever you are writing in your discussion, whatever policy you want to come up with. Okay, let's take for instance, people who got caught, that people who had female genital mutilated, who have their female genital mutilated, often have early sexual debuts. For instance, like they do have sex earlier in their age time. So you want to know, is it true? Is it not true? But we've gotten now, for now, we've gotten people that had their own courts and people that don't have courts. So the next one is I want to know if truly that people that did not have courts, just like Nigeria, we always believe that they are actually promiscuous, meaning they do have sex on time or they have multiple sexual partner. So our outcome variable then will then be, okay, do these people usually have sex earlier, or do they usually have multiple sexual partner? Now, let's see if DHS mentioned multiple sexual partner. Let me type multiple here. Let's see if we will have it on time. Because another thing is your variable, you have to know your variable very well. You have to know what your variable is. good thing is no, so sexual recent sexual activities. Let's see what is in here. Recent sexual activities. Now we are moving to modeling recent sexual activities. Somebody said, what is your recent on the field? What is your recent sexual activity? I said, I never had sex. And someone said, I've been active in the last 4 weeks. Someone said, not active in the last 4 weeks. Those are people that are on postpartum, not active in the last 4 weeks, not postpartum, like probably those are people that are abstaining. Now, we want to see what is their sexual activities like for people who had no genital courting and people who had genital courting. So we can say we can call back genital courting, and then we say space V536. V536. Now, what we have here is what we call, a lot of time we call crosstab. What we have done is we've crosstab people who had genital courting and people who do not have genital courting to their as a recent sexual activities. Now, for people no genital courting, a lot of them did not have sex, never had sex. And for people that had genital courting, some had sex. Okay. Say row, comma, row. Let's put it on percentage. What I did was to put it on percentage so that we can speak statistically. So never had sex, no genital courting, just 12%. Had genital courting and never had sex, 8. Active in recent time, no genital courting, 58. Like say 59%. Had genital courting, 54%. If you look at these, from your cross tabulation, you can actually say that people who had no genital courting are kind of promiscuous or do have multiple sexual partner or do have sex frequently. You see that you are beginning to model. Now, modeling is in about 3 or 4 stages. What we have done now by cross-tabbing no genital courting to their recent sexual activities, we cannot present this to policymakers or to intervention developers that see, I've gotten people that they did not court them like this. They just go everywhere and be having sex up and down. You can't say that, because a lot of times statistician will fault your findings based on the first level of modeling. Now, there is another level of modeling that you have to go for. It's still inferential. And so it's still descriptive kind of in nature, but a bit of inferential, which is chi-square. Now you test the association. And the good thing about chi-square is that even at chi-square, you still can't make policy. Then you have to go to what we call binary logistics regression. And another thing about binary logistics regression is that even at binary logistics regression, the level of policy or decision you can make are still limited. There are things we call covariates, which are the social demographic variables or socio-economical variables. Now, these people that do not have that genital courting, that we claim that they might be they're having frequent sex, it might be because of their condition. It might be because of their parents' income. It might be because of their parents' wealth index. It might be because of their parents' education. So what your binary logistic regression will do for you is that it's going to adjust all what we call it confounder. It's going to adjust your confounder for you in such that all those variables will be put into consideration. Then after you have adjusted for the confounder, is the father educated? Is the father wealthy? Do they stay in the rural? area? Do they stay in the urban area? After you have done all that, then if still is still associated, or is still, there is still relationship between, if you don't have your genital cord and you have frequencies, then we can now say yes, at this third level, people who do not have their genital cords do have sex frequently. Then we can submit to policymaker that, see, oh, I did my first level of cross-tabulation. It was positive. I went away. I did binary. I consider the variable alone. It was associated. Now let me quickly show you a study. Maybe what I'm trying to say, there is a study we recently, I'm not sure, there is a study we did recently. I ran the analysis with some persons. Okay, let me go to long acting in sub-Saharan Africa. I think this paper should be sufficient to just explain, since we have seen the first level of cross-tabulation, let me just show you the other level. Now this one is still the cross-tabulation. This is the association that I'm talking about. Now, what is this? What is this study trying to look at? So this study is trying to look at contraceptive use in sub-Saharan Africa, modern contraceptive use among sexually active women in sub-Saharan Africa. This place I highlighted, sorry, this is where the chi-square, you can use the chi-square to determine the association or non-association, depending on what you're looking for. So meaning, what we have done in that place is this level. Oops. Hello? Hello, am I still on?
Yes, you are.
Oh, okay, thank you. What we have done at that level is this. Now, the second level I was talking about modeling, is this. This is the chi-square modeling. Now, the third level, is this, model 1. This one that is unadjusted. What this unadjusted is saying is, like I said earlier, is that we only consider what we said. We only consider, for instance, what we were discussing, we only consider people that had no genital cutting and genital cutting and their sexual activities. We did not consider their parents' social demographic or socioeconomic variable in this place. And as such, there is still level, if you see, for instance, if you see this age group, this is called 25 to 34, was associated with contraceptive use. At this level, we still can't make decision. Now I'm going to show you why we can't make decision at this level, that people between the age of 25 to 34 that are sexually active in sub-Saharan Africa use modern contraceptives. Now, by the time we now added place of residence, we added level of education, marital status, currently working, wealth index, parity. You see that people that were significant here, when they go to this second model, this adjusted model, you see that it became, there is no star on it. That means it's not significant. You see the transformation from 3-star to no star. By the time you added all those we call it co-founders, by the time you added all those covariate co-founders, you discover that a lot of things has changed. You see, now if you see this 35 and above that use modern contraceptives, it was 3-star here, but it became 2-star here. You see, this is the typical example of modeling at the second level. At the second level. Now, there's another one we now call multi-level analysis. That is Like a comedian will say, okay, part of them all. You know, I ran one recently, just show you. That is the last one. I mean, at still the level of adjusted, which is the model 2, you can make decision. You can tell policymaker, yes, I'm sure of what I'm saying. And then now this one at the level of multivariate, which is the last everything, you can see that we have model 0, model 1, model 2, model 3. At this level is the final model of any statistical decision that you want to make or prescribe to government for policy or intervention framework. Now, what do we consider on this study? We look at the age at first birth, maternal age at first birth. We want to look at the individual predictor. We want to look at the household and community predictor. And we want to see how individual and household community predictors, how they affect maternal age at first birth. You see that people who are on their own, give birth early or they give birth later in life, like below 20 and above 20 years in Nigeria. You see, so after considering all of these, this is the first one is just a no this thing. The second one, which is model 1, is more or less like looking at it at the individual level. But let me show you something that I show you there at that analysis. Look at this model 1. Now, people who have primary education, let's use this. People who are currently employed at their individual level, they tend to give birth, according to the data, it tends to give birth above. They are less likely. What this means is that they are less likely to give birth above the age of 20 years. You see? But by the time we added all other variables, coming to this side, the 3 star became 2. Still less likely, still significant. But then the level of the significance has changed. The direction is still the same anyway. So let me now, social media media exposure. This one, media exposure. Let me use this very good example. We said people who are exposed to media are less likely to give birth below age 20. That's what this first variable is saying. This model is saying. So when we added the co-founder, when we added region, place of residence, currently working, educational level, weight index, sex, all those variables together, this change at the third model became insignificant again, which means irrespective of it, as an individual, if you are born on your own and you are exposed to media, you will have a child before the age of 20. But however, if you are in a community that is promiscuous, if you are in a household that is abusive, or kind of a household that they are poor, or in a region like in the northern part of the country where it is prevalent, you might likely have a child before age 20. Do you see the direction of the policy? No. Now, going back to our definition, we see that we've been able to fulfill all of this. We say data analysis is the process of inspecting. I've shown you how to inspect, cleaning, transforming, now modeling. Modeling what? Data with the goal of discovering useful information, which I have explained, informing conclusions, which I have said as well, and supporting decision making. It is as simple as that. If you will say you want to be a data analyst, this definition is the utmost definition from beginning to the end. If you can have this definition at the back of your mind when you have a study, and then you can pick it up from anywhere. You might not be able to do analysis to this level that I'm doing it, because there are a lot of things behind this table you are seeing, and what I've shown you a bit, there is a lot of things to it, but this is the basic introduction that we can go into. I don't now know if there will be any other section that we can now say, okay, we want to map out this. So we go into it one step by step to conclusion. Then we start making decision from, maybe we'll get a topic, or then we have a data source. I will tell you how to mine, I will show you how to mine data. And then from there, we will pick our data, we pick our variables that we analyze, univariate, bivariate, multivariate. Then probably if you can go on multi-level analysis. But a lot of times, I don't advise people to go on multi-level analysis because it's strenuous, and then a lot of times what multivariate will do, it will do it too. But you just want to show that, okay, I'm a statistician, I can go for that, and you just go, So that is it. And then I'm not sure if I've been able to touch everything little by little, which I feel by now you have gained one or two things more than now. Having this kind of session, a lot of times we take like trainings have facilitated. We use 2 weeks, having session of not less than 4 hours per day, 2 weeks, and then we take everybody home. But because of the situation of things, this is just to keep you awake. This is just to let you know what is happening in the data world. So I don't know if there is any question or clarification or what we need to do. Thank you. Hello? Is there anybody that wants to ask any question, or I think I've been able to cover like 1 hour?
My question is, what's the difference between making use of SPSS and making use of this data? Can you hear me?
Yes. Like I mentioned earlier, okay, let me. There was a study we did in Johannesburg early this year, and then when the client approached us, and it was on him and he said, we want to do this, we want to do that, At the end of the day, what we used for that project was just Excel. Trust me, it was just Excel. And I tell people
Excel.
this a lot of time. Whatever you want to do, it actually depends on whatever software you use to analyze the data. It depends on what your clients want or what you want to achieve. A lot of things that Excel can still do, that SPSS can do, that Stata can do. But when people hear the big name of R, Python, just want to show. So why I prefer SPSS, I've said it categorically before. Why I prefer Stata to SPSS, because I can express myself on Stata. It's more or less like I'm writing English. If I should show you, maybe if I share my screen and show some of my coding, you will see that it's like a very funny, it's like communicating with someone. Let me show you 1 or 2 coding. It's like I'm communicating with machine, and that's a lot through me. My kind of like, okay, but unlike working with SPSS, like this, what we call it do file. We call it do file. Now this is one of the coding. Now this do file, now you can see I said set more off, which is normal English, capture log close, log using this, comma replace. So it's like I'm just talking to the guy, okay, do this, you code this one for me, turn it to this one. But on Excel and SPSS, you have to be doing all these things manually. Well, click. But after I finish this, my notepad, I just upload it to Stata, bam, add all the variables, do this. It will just run the analysis, and I will see my results. And I'll just pick my result and start putting it in the table. with no stress. If anybody want to do another study, if you get this format and you follow it in total, you can also do your own, and then you are fine. You understand? So for me, I do not prefer any. I do not say one is better than one, but the one that make one life easier for me is still Stata, and then people that use Python too. I'm not so keen about Python, but I know how I use R too. So what is different from those?
Yes, I wanted to ask about that R, sir.
Yes, sir. What is
I
different
want to
from
ask about
R
that
is more
R
or less like Stata too. What is different
because
about?
I've been hearing people saying that
Okay,
do
another good
something. Let
thing,
me explain now.
another good thing R can do for you is what we use R for is what we call digital computational. Digital computational. Let me give you an instance. Everybody, like for instance, the number of people that are on social media in South Africa, if I get the geocode of South Africa and I upload it on how some commands, I can get the number of people who are on Twitter that are tweeting at that moment and collecting the data and their location and the hours they've been on social media. So in nutshell, why R is being invented was because it was particularly to mine data from social media. You understand? And that is what Python would do
Okay.
for you better. That is why it's just like how it's suffering, like how
It means that
SPSS is suffering now because of Stata.
So in a nutshell, you are saying that how can hello, are you there?
Hello, you're breaking. You said what?
Yeah, I said that in a nutshell, you are saying that R can both deal with data mining and data analysis.
Oh, exactly, 100%, as well as Python.
Okay.
Yes, it can mine data from you from
Okay.
Facebook, from Twitter, from LinkedIn, any social media platform. As long as you have what we call the APP manager license, then you can go ahead and it's a serious study. It's a study that I started since 2017 and I'm still on it. So it's just a small thing because it has to do with a lot of coding and learning and being tenacious about it and all that. So is there any other question, please? Hello? Uh, I think we can end the section, and if there is any question, maybe I should just I don't know if it's allowed, but you can always ask me on my social media platform. My name is Obasanjo Bolanriwa. If you put my name on Google, you will see most of my information and my social media and all that. So you can always inbox me for any clarification. And then from there, we can pick it up for in case you need anything. Um, thank you. I don't know if I can leave or end the section now since you're fine. I'm on Twitter, Facebook, LinkedIn. With my name, you can find me. So, and if